All right, and now I can officially welcome you to the first of the DiMAT webinar mini-series titled The Future of Material Manufacturing, Embracing Open Source Digital Solutions for SMEs Growth. I need to inform you that this session is going to be recorded, as afterwards we would like to share it via our social media channels for further reach to other participants that were not able to attend today's session. My name is Elish Terevat. I'm going to be your host for today. And prior we delve into the specific topic for our session, I want to give you a brief overview of the DMAT webinar mini-series and what they are all about. They're structured in 4 different sessions, each one spanning 40 minutes. And our main aim through those sessions is to give you a very brief, concentrated overview of the material manufacturing opportunities and trends for SMEs while they go on their digitalization journey. Through our sessions, we're also going to explore how open source digital solutions can support you further, and as well, we're going to introduce you to the DMAT specific solutions and how they position themselves for SMEs. Additionally, we're going to also explore different ways on how you can collaborate with us. Here you can see a very brief overview of the 4 different sessions. Today, we are going to focus on digital trends and challenges across the material value chain, where we're going to explore the main topics in this field, and also are going to give you a brief overview of the DMAT project and how we are supporting SMEs. At the end, we're going to share the opportunity for collaboration with us through the call for early adopters. On the 5th of December, we're going to move to the topic of material data management, operationalization, and lifecycle assessment. And here you can see that we're going to go through the whole material value chain, starting from data management and assessment, and also lifecycle assessment for non-specialists, which is something very relevant and interesting for material manufacturing SMEs. On the 11th of December, we're going to be speaking about predicting material behavior and advancing material design, and we're going to be discussing management of material modeling and design information, digital solutions to reduce trial and error approaches, and digital assessment and comparison for material properties. At the end, on the 17th of December, we're going to close our sessions with the topic of digital simulation in material manufacturing, and here we're going to be speaking about numerical modeling for industrial SMEs, optimizing manufacturing processes for SMEs through digital simulation, and as well about digital twin technologies. And now let's move to our session for today, which is titled Digital Trends and Challenges Across the Material Value Chain. Our speakers for today, we have Nikos Kourkoulos, Project Manager at CERT and also Project Coordinator of the DMAT project, Lucas Morant, Developer and Researcher at Fraunhofer Institute for Mechanics of Materials, Leonardo Cosma, Simulation Engineer at CHETMA, Javier Gomez, CEO at Advanced Materials Simulation, and also myself. As I have mentioned, I'm going to be hosting today's session, but also at the end, I'm going to be the one sharing with you our collaboration opportunity through the call for early adopters. Prior we move forward with our first speaker, I want to inform you that you can be asking your questions through the Q&A chat box that you see below, and our experts are going to be responding live to your queries. At the end, in case we have any additional time, we're also going to explore your questions further. And now, moving forward to our first presenter, Nikos Kourkoulos. He's going to be speaking about digital trends and challenges across the material value chain.
Hello, everyone. I'm Nikos Kourkoulos from CERT, and I will present you the digital trends and challenges across the material value chain and give you an overview of the DiMAT project. Regarding the digital trends in the material value chain, there is a trend of digitalization of processes. Automation and data-driven workflows are replacing manual processes and improving efficiency and reducing human error. Another trend is smart manufacturing, the integration of IoT, AI, and machine learning for real-time monitoring, predictive maintenance, and process optimization. Another trend is the virtual prototyping and simulation. We have the use of digital twins and simulation tools to test material performance before physical production, and saving time and resources. We have the sustainability integration. There are tools for tracking carbon footprints and material life cycle assessments that are enabling greener manufacturing. We also have a trend on collaboration platforms that are cloud-based platforms that streamline communication and collaboration across stakeholders in the value chain. Now, regarding the challenges in digital transformation, next slide. Okay, thank you. There is a complexity of integration of these digital solutions. There is difficulty in aligning legacy systems with modern digital tools across diverse operations. We have some data management issues. There are challenges in collecting, standardizing, and utilizing data effectively across the value chain. We all know that there are high costs for SMEs. The limited budgets often restrict SMEs from adopting state-of-the-art technologies. And also the workforce adoption of these tools. There are skill gaps in digital literacy among employees that blocks the adoption of advanced tools. And finally, there are cybersecurity risks. The increased reliance on digital systems amplifies the exposure to data breaches. Addressing these trends and challenges is essential for creating an efficient and sustainable material value chain. The DiMAT project provides SMEs with the tools to navigate this digital transformation and tackle these challenges. DiMAT project is focused on the development of digital technologies for modeling, simulation, and optimization in each stage of the material value chain. For this purpose, we are developing 3 suites. First, the Data and Assessment Suite that is focused on digital technologies for storing, sharing, and assessing material data. Second, the Modeling and Design Suite, which is focused on material design, predicting material behaviors before manufacturing. The third suite is the Simulation and Optimization Suite for material manufacturing, simulation, and behavior prediction. For the development of those solutions, we are collaborating with specialized partners. We have a very strong commitment from research and development with various expertise in the field of materials. We have technology providers for developing the toolkits and industrial partners like Imerys, Hegla, NaturePlast, and Setma in order to test the solution within the project. This is how we actually know that the toolkits released on the market are going to be functional and needed. The specialized partners are responsible for exploitation and standardization activities. Through our development and deployment of our solutions, we have 3 main goals: technological, economic, and societal. As technological, our goal is to provide open source solutions to support SMEs in optimizing their material production processes. As economic, we provide cost-efficient and affordable solutions, promoting the transition to industrial digitalization. And finally, as societal, our goal is to speed up the transition to a greener economy and support the sustainable goals of SMEs. So how we're doing this? At first, we started with the overall concept of the DiMAT project and suites and toolkits. And then we have run to the industrial scenarios and collaborated with the pilots to understand where to implement the solutions and what is important for them. Based on that, we developed KPIs and solutions to be working in the best way possible. Finally, we developed the framework of the DiMAT suites and toolkits. We had our first release of the toolkits, and now the pilots are testing them. As I mentioned, we're developing 3 suites that each one tackles the challenges in digital transformation and the digital trends in the material value chain. Just to give you an overview, each suite includes 3 toolkits, helping SMEs align with the digital trends. First, the suite is the Data and Assessment Suite that consists of the Cloud Material Database, the Knowledge Acquisition Framework, and the Materials Environmental and Cost Life Cycle Assessment Tool. The second suite is the Modeling and Design Suite with the tools Materials Design Framework, the Materials Modeler, and the Materials Designer. The third suite is the DiMAT Simulation and Optimization Suite with the Materials Mechanical Properties Simulator Toolkit, the Material Processing Simulator Toolkit, and the last one, the Digital Twin for Process Control Toolkit. All suites and toolkits are interconnected and can be provided as a holistic solution also. More information on the toolkits will be provided by my colleagues after. Our toolkits are going to be tested in pilots within the consortium. We have 4 different pilots. The first one is focused on polymer textile production. The second one is on advanced graphite, on advanced composite materials. The third one is on graphite, and the last one is on glass. Pilots will show the applicability and impact of the DiMAT project. The suites will be tested and validated in real world conditions, and pilots will evaluate the toolkits and estimate the improvements of implementing them. That's all from me. Thank you all for your attention.
Thanks, Nikos. Welcome, everybody. I'm Lukas Moran from Fraunhofer Institute for Mechanics of Materials, and I will introduce you to the DiMAT Digital Solutions platform. Next slide. I guess you may have asked yourself how you can get our toolkit, so you can get access. So we will provide you a DiMAT platform, which you can access from all over the world via the web. We will provide a centralized contact point that you can effortless access. The platform will give you a comprehensive access to all of the DiMAT digital solutions. With just a few clicks, you can explore, you can check demos, you can check the documentation, and select your preferred toolkits from the 3 suites. This is an idea of how we will provide you this digital solutions platform. You can, on the navigation bar, you will be able to select a suite that is of interest for you. Then you can see the toolkit that are included in the suite, like you can see here, the DiMAT Data and Assessment Suite and the Cloud Materials Database. And as said, with just a few clicks, you can get the toolkit, you can check video demos or the documentation. The Data and Assessment tool suite will also be introduced by myself in the following slides. I will start with a quick overview of some challenges that modern manufacturers have. Maybe you have faced these challenges in your company. Some of them we are also facing in our institute. Like, for example, that we need a very flexible data and knowledge management for data representation, for data storage, and for data exchange. And exchange, as we all know, gets more and more important nowadays. Also, you might have a lot of heterogeneous data sources that you need to process. We do so at our institute. For example, we have to process different data from materials characterization, like experiments, but also simulation data. And this is typically cumbersome. Also, I guess what will be the case in your company is that a lot of knowledge is encapsulated in the minds of your experts. This is also similar to here. And you may have asked yourself if there's a way how to represent or store this expert knowledge somewhere to be better prepared when an expert leaves, or to transfer the knowledge to other people, or even make it machine readable. Another point is for sure provenance and traceability of made decisions. So typically decisions that you make at your company, or that we also make here, they have a long information chain in beforehand. So that means, for example, you have an experiment from which you get measurements, you have to process the data shows something, it will be assessed, and so on and so on. And at the end, you make a decision maybe to change your process or something like this. And yeah, this needs to be traceable, so that, let's say, in 2 years, when I come and I ask, hey, how did you do this decision? You should know everything about this whole chain. So this is provenance and traceability. And last but not least, what do you do with the data? You need to assess the impact of the product based on your data. And this is also getting increasingly important and complex if you think of societal impacts, but also economical and ecological impacts. So here the three toolkits of our suite comes into play, which are the Cloud Materials Database, the Knowledge Acquisition Framework, and the Materials Environmental and Cost Lifecycle Assessment tool. I'll start with the Cloud Materials Database. This is a modern database solution for efficient handling of materials and process data. So if you if you use this database, you will be able to integrate or upload data of different formats. So independently of the format and of the data source, you can integrate this into the database, and it will be represented there in one unique format, which is machine and also human readable and also AI ready. Also, you can link this data together, which means that you can represent complex information chains, which will also help you to trace your made decisions. Then the knowledge acquisition framework. This is a knowledge graph-based framework for storing materials and also process information. So knowledge graphs are quite novel methodologies to store data in a semantic way. This means that you do not just store the data as is, but you can also store relations between the data. So if you think of classical databases where you store, like, for example, a material parameter and a value and a unit, this is not This is not understandable for everybody on the world. Like, if you give that data to some non-expert, he may not have an idea what this means. But if you store it as a knowledge graph, you can link it, like the parameter has a value. The value is, like, say 200, and it has a unit, and the unit is gigapascal. And then you can even put or add descriptions. What does the parameter mean? What does the unit mean? And so on. So here also machine and human readability comes into play. Last but not least, we will provide a high-level life cycle assessment tool. So life cycle assessment, as I said, is getting increasingly important, but it's also very complex tasks. A lot of data needs to be assessed, and this is typically quite difficult. So, but this tool will help you to do this in an intuitive way, and the whole suite together will give you a seamless integration of all these toolkits, so you can use your data, store it, exchange it, and assess it afterwards. All of this so yeah, you will get a simple but effective data knowledge management and an intuitive lifecycle assessment.
Okay, thank you, Lucas. I'm Leonardo Cosma from CETMA. CETMA is an acronym that in Italian stands for Technologies, Design Materials European Research Center. And today I will briefly introduce some concepts about possible challenges and needs that the DiMAT modeling and design suite can help to overcome and to address. One problem is the selection and optimization of the materials. The choice of the appropriate materials to be used for specific applications is quite important, of course, and cannot be based only on performance requirements. We all well know that other than performances, it is important to consider cost efficiency of a solution, and also external requirements that could be specific regulations or environmental consideration. And often these aspects are connected and overlapping. And so these make the design process a multidisciplinary activity. It's not only science and material anymore. A lot of different aspects need to be taken into account. Another specific challenge that our suite aims to address is the influence of the formulation and processes of the material itself. Especially in advanced fields, it is really important to not only to quantify and assess the effect of, let's say, composition, treatment, on what will be the material behavior. Another important issue is to discover hidden correlation, hidden effects of something that happening in the process that can significantly alter the expected result, the expected behavior of a material. And finally, and connected to this problem, we also consider the necessity of understanding what happens into a material. Not only considering this material as a black box with some input parameters, again, composition, processes, and some output parameter like its mechanical properties. Modeling and simulation is an important tool that can help in understanding from a physical perspective what's going on and explain what we can observe externally. Another concern could be the gathering of data needed to understand the behavior of materials. Testing is the only way, But of course, testing is expensive and takes time. So a possible solution to this problem is the virtual testing, using digital models to gather data and to better understand what is the material behavior and why it is in that way. The modeling design suite offers 3 toolkits able to answer to these needs, and each one with specific approach. Our mission is to have these toolkits integrated into pre-existing workflows of companies, allowing to obtain improved products in a more efficient way. The first of these toolkits is the material design framework. It is an open knowledge system that can support the material design process in different ways. But the basic principle is that it finds information, exploring the available data space, and then generating new knowledge from that. Possible application of this toolkit are finding correlation between how the material is being processed and its final performances, for example. This toolkit also aims to provide easy access to material modeling knowledge, which is constantly growing and therefore can be challenging to enter. The second toolkit is the material designer, the material modeler. This tool makes a large use of artificial intelligence to support the process of material modeling in different ways. Again, it is very useful in analyzing existing data and find patterns and useful information. But most importantly, this toolkit is able to predict the properties of a material based on, let's say, its process parameters or the amount of additives or the specific formulation used. This toolkit also includes a local open source large language model to interact with it. The third toolkit is the material designer. This tool is focused on complex material and the analysis and modeling of their internal behavior. This toolkit aims to assist the user in designing new materials by allowing to evaluate a great number of different configurations, different solutions, without physically testing them, because the testing is done virtually using specific numerical methods. Now, in conclusion, I just want to briefly recall the pillars that have driven the development of this suite. First of all, the use of a robust artificial intelligence framework to assist the user in the operations. And AI is not just used because it's trendy, but with specific goals and setups in mind. And then we have adopted different and complementary approaches to look at the problems with different perspectives. In fact, we use different technologies ranging from more traditional numerical approaches to the latest AI features in our models. And finally, we adopted a customer-oriented approach. These toolkits are open to be extended to incorporate additional features or specific models that the customer could need during their activities. And that's all about this modeling and design suite.
Thank you, Leonardo. This is Javier Gomez from Advanced Material Simulation. We are going to see now the third suite, the Simulation and Optimization Suite, regarding material modeling, process, and digital twin. And in this suite, we face some significant challenge that we have in material manufacturing. Nowadays, we are living an interesting situation regarding technological and research due to the emergence of new elements in manufacturing and the emergence of new innovative manufacturing technologies. For example, new advanced composite, hydrogels, or polymer blends. Additive manufacturing, hybrid manufacturing are new elements, and it's important that all new elements require a specific type of modeling. We cannot translate classic modeling to all these new elements. Overall, dealing with modeling, we are living a modeling revolution these days, mainly due to the emergence of the artificial intelligence, but also due to some important development in multi-scale and multi-physics simulation. We have now a lot of possibilities of using modeling. We can use physics models or we can use data-driven modeling, artificial intelligence models to solve industrial problems, or we can use new multi-scale using atomistic simulation to macro models or combination of different multi-physics simulation. All these possibilities are open new possibilities, new possibilities to solve our industrial problems. Basically, the main advantage is the increment in computational capabilities. We have now more computational possibilities than some years before, not only due to the appearance of GPU, TPU, and this element, but for our company, for an industrial SME company, we have the possibility to externalize all this part. So we need to choose which is the best option in this very huge field, in this very huge set of tools. For a large company, we can solve this with a very huge engineering department, but the situation is different for SMEs. For SMEs, we need to choose correctly the specific tool. We can choose commercial tools, so it's very powerful tool with some barriers, some cost barrier is could be difficult to avoid, and also it's difficult to use different toolkit, and the interoperability between different toolkit is a challenge issue that we are going to solve with our suite. In suite 3, we have 3 parts, 3 toolkits. The first is the material mechanical property simulator that focus on predicting the mechanical properties of material, but also we model components. The second is a material processing simulator, focus on analyze simulator the industrial processes, and the third is digital twin. Probably the third is the most disruptive element, but all the 3 toolkits are incorporating cutting-edge solution. For example, at the first toolkit, we are incorporating multi-scale modeling in combination with multi-physics to solve the industrial problem. At the second toolkit, we are combining multi-physics with artificial intelligence to reach real-time model. And the third toolkit, digital twin, is clearly a new element. Probably the most interesting element of this suite is the possibility of the combination of the 3 toolkits in one. We can predict the properties of material component, but we can also model with atomistic and multi-scale model. We can also include this part in material processing simulator toolkit to analyze the simulation of an industrial operation, or dealing with digital twin. We can substitute the data-driven model of the digital twin by a real physical modeling working in real time. One of the most interesting properties of the suite is this capability of working in real time, and that we have achieved combining physical simulation and training new artificial intelligence tools with our physical simulation, and the final output is a model that can predict in real time the performance of our component of process. The second advantage of our toolkit is that we are using open source tools. And the open source tool that we are using is Calculus, OpenForm, ParaView, PrepoMass. Is robust solution. We are not using we are using well-established open source tools. This gives us reliability of our model. we have the possibility of customize our model, not only at the backend level, also at the front end. So our solution are adaptable to a huge variety of industries. We have check our possibility in 4 pilot, but we can extend our offer to any kind of industrial industry. And we are developing accessible and user-friendly interface and very easy to manage. And this point solve the typical problem in open source software dealing with the hard learning curve. And in conclusion, we are developing a powerful suite combining these three elements, trying to democratize in a certain way the engineering research, the engineering recent advance to SME companies, to the global SME companies. Thank you.
Thank you all. Now, thanks to our speakers, I hope that we have a very good understanding on what are the current trends and challenges for material manufacturing SMEs coming when we come to digitalization and their digitalization journey, and how open source solutions and specifically the DiMAT solutions are here to support them. Now, after this presentation, we would like to invite you to collaborate with us. And how this is going to happen, we are launching a call for early adopters in December, so pretty soon. What is our aim through the call for early adopters? The main reason is that we want to engage with potential end users and early adopters that can provide feedback to our solutions so we understand the product market fit and develop them in the best possible way to accommodate the different SMEs needs. How this is going to happen, the expression of interest is going to be launched as stated in December, on the 17th of December, and this is going to be open for 2 months. After the application process, several companies are going to be selected and they're going to be collaborating with us for a period of 2 months. This is anticipated for March and April. What is the value proposition behind our call for early adopters? Not only that you're going to get early access to the DiMAT solutions and you're going to demonstrate how they're operating, but also you're going to be able to work with them and see how they are going to be useful for your processes, but also you're going to receive tailored expert guidance from our consortium experts, as you say. So we were working with a wide variety of different organizations spanning across Europe. They're going to provide you with further support on your digitalization needs to enhance your business and operational processes. Additionally, you're going to understand what are the current trends and the developments of digitalizations of digital solutions for material manufacturing across the material value chain. And not only that, but you will be supporting DiMAT solutions to be developed in the best way possible for SMEs beyond. At the end, we're going to provide you with very prominent communication and dissemination exposure through our different marketing campaigns and through our website and social media channels, through spotlight articles, and much more. As I stated, this is going to happen to a very brief application process. You would need to fill in a short form on the F6S page. After you do this, we're going to evaluate the companies and organizations that are most fitted to our call for early adopters and what is possible behind it. Apart from the companies that are going to be selected, since we're not going to be able, of course, to work with everybody, nevertheless, everybody who is interested is going to gain access to our discussion forum, where we are going to receive different information on specifically the topic of material manufacturing. You can post your questions there and receive information from our experts, and we're going to provide you with the latest developments in terms of research and opinion articles, but also events in the field. I think this is it. In case you have any questions now or later, you can come to us specifically for the call of early adopters. This is going to be launched on the 17th of December, and you're going to have access through the DiMAT website and our social media channels. Specifically, you can follow us on LinkedIn and Twitter. And I think this is it. I would like to thank all of you for your time and to our speakers for those excellent presentations, and would like to invite you to follow our upcoming webinar mini-series, with the next one to be held on the 5th of December, as stated in the beginning of the webinar. I would like to wish you a good day. Thank you for attending, and see you soon.